Good morning, everybody. If you're out there watching live, we're on a bit of a weather delay. We got a little bit of snow in the air, and we're concerned about aircraft icing. So please stand by.
Go ahead. Good morning. This is Garrett Seddon from the COE, giving you an update. We're on a weather delay, so once the weather clears up just a touch for us here, we'll get on the way. So thank you for joining us, and stay tuned.
Good morning, everybody. Sorry we're having this not optimal weather. It's a little snowy here in Rifle today, and it's kind of delaying us, but we are going to be flying in a while, so please hang on. And we got some exciting things for you to see today. Thanks. The view you're seeing on the screen today is from a camera up on the mountain, probably about a quarter mile away from us. It's being relayed through radio links to our office in Rifle. That's a tilt and zoom camera, and we'll be using that to watch the launches. We'll zoom in. That launches today will be launching from the catapult that's in the display right now.
Good morning. Good morning.
I can't hear a damn thing you're saying.
Good morning. We'll be starting in about 2 minutes. All right, we'll go ahead and get started, guys. I want to say thank you guys for all coming out to the long endurance field test. Welcome to beautiful Colorado. We brought out the sun for you guys. Nice warm day. Today we're going to be looking at 3 aircraft, how they can be a force multiplier on wildland fire operations. We have UND Aerospace Foundation, Aero Watch, and then Aero Environment. So they're all going to be showing off 3 different types of that they can do wildland operations. UND Aerospace, Dana.
Hi, good morning everyone. I'm Dana Sandy from the For any of you that aren't familiar with the University of North Dakota, we are the pilot training school in the entire world. Right now we have over 1,600 active pilot students training in commercial aviation in Grand Forks, making the Grand Forks Airport the busiest airport in the United States times in the last 21 days. We're busy in Grand Forks. But it's certainly very nice to be here in Colorado. Again, for background, UND Aerospace, this is our 52nd year training pilots in Grand Forks. We are also the largest air traffic control training school in the United States, anywhere from 250 to 400 undergraduate students annually. We're very fortunate that in 2005, the great Senator Byron Dorgan from the state of North Dakota provided an earmark to the University of North Dakota to start the UAS Center of Excellence at the school. From there, we acquired a PMATS, a Predator Mission Aircraft Training System. And so we currently are providing support in Grand Forks for General Atomics. We started our full being the first university in the United States undergraduate degree in unmanned aircraft systems. It was the fastest growing undergraduate program at UND. A couple hundred students right now. So if any of you are looking for graduates that are well trained, they ultimately get some time in the Scan Eagle in Grand Forks as well. So good quality students. I'm going to introduce Ryan Walsh. He's our mission today, and he's going to be for our flight.
All right, hello everybody. Ryan Walsh, UND Aerospace. I'm going to be the man for the Penguin operation. We're flying the Penguin C UAS. It's a catapult-launched, parachute-recovered aircraft. We've got between 16 and 20 hours of endurance, multispectral sensors on board, infrared and high-definition. My crew with me today is Scott Kraber, remote sensing specialist, came from the University of North Dakota academic program, where he taught most of the UND UAS students all about remote sensing, radio signals, and things like that. He is also an FAA certified avionics repairer. Next to him, we have Fabrizio is in air traffic control. He's controlled airspace in I have rating on manned aircraft as well as my unmanned rating. We do have some just so you guys have an idea of what is going to be primarily orbit set up, just to make sure all of our aircraft systems are. And we will increase altitude and basically sit over the ground so that we can get our be able to show you guys the best available pictures that we've got. Flight duration, we're planning on about an hour and 50 minutes to get the aircraft back in, and still have some time to answer questions if you guys have anything. Our recovery plan, we will be coming once again from east. It's a parachute deployment, so we will deploy our parachute at about 300 feet above the ground, and should be make sure that our flight paths are as far away from most of the people as we can. If we do have our in-flight emergency plans, if we have a lost link, we have our aircraft will automatically recover to that spot. If we have a power failure, we will basically glide to a safe place, make sure that we're clear of people and property. Loss of GPS, we will deploy the parachute. Flyaway, we have the aircraft geofenced into this area to make sure that we don't go near Rifle or near Garfield County Airport. Obstacle avoidance plan, we got some cumulogranite clouds that we don't have in North Dakota that we'll avoid. So this is a little bit of a new environment for us. Estimated number of flights, we got one. Environmental weather is, we've got what we've got, so we're going to fly as long as we can, as long as we have visibility. We do have an area marked off down there, so when we're doing the launch, we've got everything marked off by cones, and that's our area that
there, but once we're off the ground, if you could come and huddle between the, you can see we have some chairs set up. Also, the trailer is warm, and there's seating in there for anybody that may want to come inside.
Yep.
Okay.
Just the other thing that we're doing is we are monitoring Rifle Garfield County for traffic to make sure that we don't have any traffic in the area, so we'll avoid any man traffic if there is any in the area with, yeah.
Yeah. Great.
Thank you, gentlemen.
Okay.
Get ready to watch your bird launch. All right. And for those that are on the live stream, UND Aerospace will be launching the Penguin C aircraft, which is a launching system. And we will be seeing that here shortly. We'll zoom in for that, and then we'll try to pan the camera for you to observe the launch. Thank you for tuning in today.
If you look down in the distance, you'll see the aircraft on the catapult. They're getting ready to launch. So just so you know, that's kind of a misleading. I think the camera picks up the snow. It's not nearly that intense. Hang on, this should be fun.
No.
I think we're getting pretty close to the launch.
Environment has
The aircraft that's being
the UND Aerospace Foundation is still doing their checks for the it is the white and orange aircraft. They're going to roughly fly for about an hour and 15 minutes through some light snow. So please stand by while we continue to observe the aircraft get ready to launch. today. They're going through their final checks, ready to get ready to launch. Please stay tuned. It'll be launching here shortly.
I'm hearing better there.
Yeah, but I mean it's not consistent.
So
In theory, this is on.
testing. 1, 2, 3.
Oh, it's in slot 2.
Testing. 1, 2, 3. Testing. I'm getting it there.
Oh, and it launched. It was gone like a shot.
Okay.
And the aircraft
See if I
just
can find
launched.
it on
It is
this
going
camera.
into the air now. It sounded like a small gunfire shot, but it's disappearing off into the low base that we have here in Rifle today. And again,
That doesn't sound bad.
Yeah. I don't think this is the microphone, the audio input too.
That's
But I'm not really showing anything at the moment with my camera.
yeah. Yeah. I'm not sure if that. Are you hearing anything audio come out?
Yeah, there's a lot of just ambient audio. I'm pretty sure it's your laptop.
Foundation England C is due to where they had a monitor reviewing down there, and unfortunately we'll lose. I don't know if we try we will keep updated on about an hour. We're going to try to get another feed in here to watch the camera through the air. So please stay tuned. Thank you for joining the Center of Excellence today in snowy Colorado. UND Aerospace Foundation aircraft, the Penguin C, is still up and flying. It is flying in circles right now, trying to locate a target through ideal fire conditions through the snow. So we will keep you updated as it's a parachute type landing system, so it will be fun to watch when they come in and land. They'll be right here in front of us when they do that operation. Thank you and stay tuned. Work phone, not
Okay, now we're going to walk out there and do a little coffee.
Hello, this is Garrett again. We have the Penguin C from UND Aerospace Foundation flying above us. We can hear it, but you guys on the live stream cannot. They are broadcasting a feed down to their command center down there where all the spectators here are huddled up, looking at the images that they can see. I'll briefly walk down there, take a look, and then I'll come back and talk to you guys on the live stream. Thank you again for joining us today. That's John. Hunter is the guy with the sunglasses on his head, and then the guy with the navy, is Robert. So yes.
Stay there. Give me a little talk. Just a real brief talk.
Hello, UND Aerospace Foundation is still flying their Penguin C. We can hear it buzzing above. Getting ready to walk down and see what they're showing the attendees down there, and I'll try to talk to you while I'm down there. Thank you for joining today. Testing. I'm at the UND Aerospace Foundation Command Center. Looking at the images here, they're showing the camera feed coming in from the Penguin Sea, looking down at the ground, highlighting the capability that they offer.
We can change that on the fly. We can change it to a
Forks.
Hello. UND Aerospace Foundation Penguin C is going to be coming in for a parachute landing here momentarily. So we're getting the camera set up for you guys to be able to see that. The aircraft has been hovering around in the air taking looks at the attendees and different vehicles. It has been switching back from thermal and visual cameras while it's been circling above, cutting through the cloud layer that we have here in Rifle today. Finally quit snowing here. The sun is trying to poke through a little bit, but our base of the clouds is still a little low, so we will try to get it as close as we can. The UND Aerospace Foundation has to be further away from our setup up here because of the launching system that they use. You guys weren't able to necessarily hear, but it sounded like a small gunshot when it launched. It was pretty impressive, a lot of power behind that launching mechanism. And inside the command post, they have two operators, one pilot who is navigating the aircraft, looking at different targets, and they have a system operator that is looking at the specs of the aircraft, making sure, looking for icing, looking at weather conditions, watching for man traffic, and looking at the external information that the aircraft is sending down from the sky. So again, briefly here, the UAV from the Penguin C from UAV Factory will be doing a landing, and it is a parachute type landing operation. So this is the 5-minute warning for that. Thank you. So while UND Aerospace Foundation is bringing down their aircraft, we'll pan back to that as soon as we see it coming in for landing. Overwatch Aero here is getting their aircraft ready. It's the Harris Latitude FER-90. The individual here is moving through the pre-flight checklist to get the system operational. The type of aircraft this is a VTOL, vertical takeoff and landing aircraft, so it takes off like a quadcopter that you guys are familiar with, and then transitions to fixed wing flights, so that push-pull prop on the end there takes over, and then they will climb to altitude and begin the operation. Again, this is Overwatch Aero with the Harris Latitude FER-90 going through their pre-flight. UND Aerospace Foundation is coming back in with their Penguin C aircraft for a parachute landing. Stay tuned. UND Aerospace Foundation is sending their ready for recovery. Guys out there is coming in for recovery. Landing here. Again, that's the Penguin C aircraft. That's going to do a parachute landing here. So we have the camera set up. It should be coming in on your screen from the right to the left. And you can see the green going out there right now to acquire the aircraft. The next aircraft up is going to be the Harris Latitude, the FER 90 from Overwatch Aero. They will be demonstrating their aircraft and what they can do for wildland fire operations. Thank you for tuning in today. We will be seeing the aircraft land here from the UND Aerospace Foundation. In correction, the UAV from UND Aerospace Foundation, the Penguin C, it did come down already. The two guys are going out there to recover the aircraft now. It came down on the parachute and came down pretty slow. So nice and easy recovery. They're going out there to get it right now. Here shortly, Overwatch Aero will be launching their FER 90 Latitude.
Okay, for you out there in YouTube land, we're moving the spectators up locally, and we'll be launching the other second aircraft from a moment. It's a vertical takeoff aircraft. It'll launch from right in front of the camera here, so hopefully that'll be a good view. We'll be repositioning the camera here momentarily to be able to watch the VTOL takeoff. And then that aircraft, we have access to the display that's seen from that aircraft. We can feed it in through what's called back, and we'll make that live once we have it working shortly after takeoff. I'm going to give you a little bit of a close-up tour of the aircraft here. As we talked about, this is a vertical takeoff aircraft, so it will take off like a helicopter or like a drone, like a quadcopter. If you look closely, there are 4 propellers, one right there, a second right there, and then there are 2 on the rear of the aircraft. Those are the vertical takeoff propellers. They will spin up and lift the aircraft vertically into the air about 75 feet. And this pusher engine, which is a 2-cycle engine, will kick in, and the aircraft will transition into horizontal flight. As you see that transition, what you'll notice is the right wing will dip, and that's as they throttle up the 2-cycle engine. It'll dip pretty dramatically, and then the aircraft will transition to a flight mode, and those vertical takeoff propellers will stop and lock into the position you see them here, which is a feathered position, so they allow the aircraft to fly. This aircraft can fly something like 16 hours on a full tank of 5 gallons, I believe it is, of gas. Its maximum takeoff weight is something like 110 pounds. We'll get more update from the crew on this when they get ready to launch, which they're working towards now.
All right, we're getting the next one set up here. Overwatch Aero is getting ready to take over here with their Harris Latitude FER 90 aircraft. So 3 minutes until they start their operation presentation. All right, for those that are here on the live stream and in person, we're getting ready to hand it over to Overwatch Aero to demonstrate their aircraft and how they can be a force multiplier. I'm going to hand it off to Chase so he can get right into their operation. Chase?
Thanks, good. Hey, good afternoon. How's everybody doing? Good. Good. Awesome. My name is Chase Pietenpaul, along with my partners Jordan Hahn, Jeff Strebler, and Tanner Hahn. We are representing Overwatch Aero today. We are a data collection and dissemination company out of Central California. We tend to use long endurance unmanned systems to provide persistent real-time intelligence products to first responders, wildland firefighters, search and rescue teams, and then other requirements as necessary. So today we'll be operating Harris Latitude FER 90. The airplane is about 16-foot wingspan, grosses in about 120 pounds. So the magic of what our company tries to do is take that bus, put different sensors over target, and collect actionable or information that can turn into actionable intelligence, and then disseminate that in near real time. So that'll be what we're showing today. Flow of events for our demonstration will be this. We'll go directly into the pre-mission brief. We'll go engine start and we'll launch. So the mission brief will take probably 10 minutes. Launch sequence will probably take another 10 to 15 minutes. And then after that, we'll go into the details of the data collection and dissemination portion. And then at the end, we'll have a recovery brief. We'll bring the airplane in, and then we're more than happy to answer any questions that may arise. So with that, I'll pass it over to the pilot in command, Jordan Hahn.
Thank you, Chase. Good afternoon, good morning, everyone, whichever one it is right now. We're going to run through the flight brief real quick, and then we'll get onwards with the fun. So, starting time hack, I got 11:31, 23 March. Objectives for today are the successful launch and recovery and demonstration of November 170 Whiskey Alpha, which is our airframe there. We're going to launch her, set it up out here. Like Chase mentioned, it'll be about a 10 to 15 minute process where we'll be doing some of the pre-flight checklists and everything. We've run the checklist up to a point so far. We'll pick up with that with engine start and continue on from there. Quick safety item before we go into any further the plans. Once got the aircraft engine on, we're going to ask everybody to be behind the fence here just for a safety precaution and let the guys in the field do the launching. And at no time, please ever put yourself between the airplane and something hard. So we always ask to have, just don't ever get yourself in a scenario where you may get squished. We all trust it, but it's just a quick safety reminder up front to make sure that you got a good safe distance from the airframe. Launch plan, airspace for today, we're going to be operating surface to 1,200 feet per ARCOA. We're going to be operating launch and recovery in this area here, and then we're actually going to be going up on top of the plateau and orbiting up that way to get a good view up that way. So from surface to 1,200 feet AGL. Launch plan is going to be setting up here. Like Chase mentioned, she's a helicopter. She'll go up to about 75 feet. Then we'll transition forward out towards that field. We'll loop back, set up an orbit here to make sure that we're happy with the airplane. Once we're happy with the systems, we'll push it out that way and then up over the top to the ridge. And then landing plan, assuming the wind stayed the same right now, she'll enter a standard left traffic flow, come down this way, transition back to the helicopter, and then land vertically, almost the exact reverse of the launch plan. In the event we lose communications with the aircraft, it'll come over here and it'll establish an orbit right over here at about 500 feet. That'll allow us to attempt to regain communication. If at any time we can't, then then we'll proceed to land just for the standard land plan. So nothing out of the normal landing if we do lose communications. Emergency plan, so abort authority will lie with the Overwatch crew. So these 3 members outside, anything said in triplicate, for example, abort, 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 inside I'll respond as pilot in command with abort commanded, and we'll execute the abort phases. Any other emergency that can be worked that's not safety flight critical, we'll get her in that orbit, we'll address the situation, make a logical conclusion from there, and then bring it into land in the event of that type of emergency. For those that haven't seen this before, there's several phases of flight for this type of aircraft. So there's what we call liftoff, which is where it's going up like a helicopter. In the event that I abort the liftoff there, it'll go right back to what we call touchdown mode, which is where it's going to come land like a helicopter. If we abort in what's called launch transition, where it's that hybrid half helicopter, half airplane, then it will either try to come back to the point and land like a helicopter, or we've got a spot out in the road out there that it's identified that it will put itself down like a helicopter out there safely. If we abort while in the air, it'll come to the lost communications orbit and hang out there until we give it other instructions. And then on recovery, kind of the exact opposite. If we're in that transition phase where it's coming in and switching from plane to helicopter and we abort it, it'll just go right back off and continue flying. And then if we're coming down like a helicopter in touchdown mode and I abort it, it'll go back to liftoff. So we'd like to brief all those just so everybody, if you do hear that called out, and we all know what the corresponding command is. Hazards for today, this is a relatively new environment for us, so we always like to acknowledge that. Weather is a factor. Right now it's clear and good, but we'll keep an eye on if the winds shift or if any other type of precipitation moves in. And then just acknowledge we've got a lot of visual observers, so please make sure, again, safety's first. Make sure we're never in or too close to the aircraft during operations. Personnel, I'll be serving as pilot in command. Chase will be the support personnel out at the aircraft. Tanner's working as visual observer, and Jeff's going to be the relay for communications here in our go-between. Everybody else, visual observers and participants. Just a couple quick notes on the phases of flight. So you'll hear us doing a lot of communications. Everything up until you hear flying, which is what Chase will yell out, is considered a critical phase of flight. So we're going to treat it like a sterile cockpit. So we ask everyone to minimize communications during that. Once you hear flying, that's when the autopilots transition to a nice happy mode. We're happy with the airplane. Feel free to ask questions and kind of bring up the conversation then. And then same thing on recovery. We'll announce when we're coming in for recovery. We'll treat that again as a critical phase of flight, maintaining a sterile cockpit until she's safe on deck and we call engines killed. So with that, any questions first to our team? Anything I missed?
If you guys could, I'll be the relay, so I'll be talking with the pilot and looking at Chase. If you guys could just leave me a little space here so we can do, we do hand, we don't do mics. It takes longer to go like this than it does to go like this. So just leave me a little bit of room and then we'll transition back and forth.
Chase, you want to describe the takeoff?
Yeah, one other outline. When this airplane launches, she's big, right? And there's a lot of moment arms associated with that. So as we spin up those VTOL motors, there's a good chance that you'll see a little bit of twitchiness on launch. Completely normal. If we had a little bit more of a headwind, those twitches go away. She's actually tuned to fly in higher headwinds than what we're flying today, and that just opens up our envelope. Completely safe, but you will see just a little bit of twitchiness when compared to a small quadcopter, just because of it. The other thing is once we transition at about that 75-foot mark, you're going to see a very pronounced wing dip. Again, completely normal. That's just the pusher motor throttling up, and that's an action-reaction, just a torque thing. Newton figured that shit out a long time ago, but that's what you're going to see. And then you'll hear us call flying, and you'll see a dramatic pitch up. The only thing I would echo is, if you wouldn't mind, don't put yourself between something hard and the airplane. Don't get squished. I'll be asking.
Okay. Any other questions or alibis before we go fly?
Sweet.
All right. Thanks, everyone. Thank you.
If you guys want, we have these cards here. I grabbed it before. These have the,
Chase, who am I passing this off to?
the camera directly to your phone. The other one,
I'll pass this to you while we launch, and then I'll take it back.
landing or takeoff pre-checks right now. I hope you can hear the aircraft in the background running. Hope you can hear me over the aircraft. We'll see the VTOL propellers spin up here in a moment, and then they'll take off. I'll try to track it with the camera. He's connecting the VTOL batteries now to make sure it's ready to go. That's the last step before they will test the VTOL props, and then it will spin up. We should see those VTOL props spin up here momentarily. There they are. They're spinning up. So we are getting very close to launch. Guy's clearing the area. He's picking up his starter tool. And I will do my best to follow this, as will Brad with the mount camera. VTOL props are battery powered. They're used only for takeoff and landing. Once it's up in the air, it's running on the gasoline engine. I think I just heard him say we're good to go. There we are, spinning up the props. And there it goes. You'll see the right wing dip as the motor spins up. There it goes. And it's flying. It's transitioned into flight mode now. Its VTOL has shut down. The aircraft is now flying as a conventional aircraft. I'll try to follow it, but as you can tell with a video camera, it's pretty hard to follow. I'm not able to see if Brad's able to follow it better with the mountain camera. We will be switching over to a feed from the drone here momentarily, so we'll be able to see what the drone sees, and I'll put that live. I think I'll zoom out on the video camera here because while I can see it, I'm not sure you can. It's coming towards us now. I don't know if you can hear it in the background. He's climbing to some elevation, quite a bit above us. This aircraft is flying under a COA that allows him to fly considerably higher than a typical drone. And I think we'll move over to the other camera for now.
The aircraft is still gaining altitude. It is circling out here. We are trying to switch over to the mountain feed so we can see from the footage there. The sun finally decided to come out, so it's playing a little nicer with this aircraft. So here's here shortly we will hand it over to one of their representatives so they can talk through what's going on for their operation. This aircraft and this team also integrates into the team awareness kit, and if you check the YouTube chat there's a link to their GIS that can provide video input and how it overlays onto a GIS map. Aircraft is still hovering to gain altitude, and I'll be handing it off to one of their representatives to talk about what's going on. Thank you for listening in. The L3 Harris Latitude FVR 90 is flying back through. It is still circling to altitude as they get their system set up. It is increasing in altitude in the clear weather that we're currently having.
Sorry, say that again?
The endurance on the platform?
16 to 24 hours, depending on how we're set up. How we're set up right now, we're looking at about 16 hours.
Right now we're looking into Overwatch Aero's command suite here, looking at their system operator and their pilot navigating the aircraft. You guys aren't able to see it at the moment, but they're zooming in on where all the attendees are and gaining altitude.
It's we basically treat the plane as a relay. So we get fires on the ground. We have a locality box that goes through the IP and the router on the airplane. And you
just
can call
watching
in.
it. I was just that's what
Just showing you, yeah. You
yeah.
can.
So we'll have the
Green
food up
meter,
here in just a
Jeff.
second.
Yeah, Jeff
was
showing
telling
you
us.
that. Yeah,
he
you can
was
call
telling
right
me,
into
he
a guy.
gave us the card and
Hey, put your hand up.
right.
Seconds later, through your phone or through your radio. It's pretty neat. So you know. We can overlay it onto, he's written code to overlay it onto X-Plane Simulator. So we have an X-Plane Simulator with the plane flying, and you can see all the situational awareness traffic around you. So, anything you want to add to that, Jeff, that I think of?
We take our own position as well, so we can see our own position in relation to other aircraft that are out there. Just like in flying main aircraft with ForeFlight, if you're getting too close, somebody's got the same heading as you, same altitude, it goes out, it gives you a warning. And, yeah, basically it's almost like TCAS, traffic collision avoidance. So we can go, oh, there's somebody coming at us. Let's climb, descend. We'll probably descend. It's easier for us to descend than climb. But even climbing higher altitudes is a little bit slower. But at lower altitudes, you're looking anywhere from 700 feet to 1,000 feet a minute of climb.
What was the other fire? From the line fire?
The Lime Fire and the White Wolf Fire.
Okay.
And then we did the Bryceburg Fire a year before that. So once we get it up and running, like we talked about earlier, we can give you guys real-time imagery. You guys can talk to the sensor operator. We've made it so here pretty soon, hopefully, we'll get it tested today. You can have an ATAC user. We feed straight into ATAC as well. They can actually take over the camera also. So as we're flying around, ATAC can send the operator and go, hey, I want to see here. Right? So scan over, it'll do that. Our web app that I showed you, we can go in, we can take your night IR flight, overlay that straight into ArcGIS, which publishes to our web app. And then as we go, we can actually add to that, give you new lines, and then you can see real-time data, and then you can see your location. So if you're, within so many feet, so many miles, whatever, you can see where you're at comparatively. So if it's time to go, it's time to go. So you guys are more than welcome to hop in the trailer and everything else.
All right, so what you can see, well, a little choppy video here, we'll get figured out in a second. We got the video coming down. This is ArcGIS Pro. For those that have done GIS work, one of the main GIS mapping programs out there, especially in the wildland environment. So what we're able to do is pull the video in live. Of course, it's hiccuping here at the moment, so let's let it reconnect. Once we get it back, you'll see the videos here, and then we can pull in an incident map over here. So any given incident map you'll have in comparison will be right in side by side with us. So you can pull in whatever your GIS analyst for the incident has pulled. And then once we get good video here, I'll show you. So now what we're able to do is interact with the video, and we're able to use georeferences straight off of the video and input features into the environment. So let's go. Jeff, can you give me a viz, please?
It's coming right now.
Okay. Did it come up on your phone? So you should be, yeah, these two things here that you'll see, we've got the live feed, which is a high resolution feed, which is just video. So it doesn't have the geospatial metadata along with it. And then the GIS website is essentially a web version of ArcGIS here. So it's able to provide somebody in the field who's got internet connectivity with the live video, the geospatial metadata of where the camera's looking, so what's the context behind that video, and you're able to share incident maps. So here in a second what we'll do is we'll pretend this road's a fire line, we'll map it, we'll save it, and then everybody's phones, once you refresh, you'll now have that data that was derived from the video within a minute or two put out to everybody's phone. And so it's able to take video, which is cool, but really turn it into that data that what we want out of it, right? Because video is only, only cool for so long. So if we go, Jeff, if you can get me a road or something still so I can interact with here.
Yes, sir. I'm not operating the camera.
Oh, okay. So let's say, for example, we wanted to come in and say we had an uncontrolled fire edge somewhere. And once the guy's inside, steer the camera to a spot. Just keep it right there, Jeff. Hold it still. And I'm also working this through a mouse. But anyways, we can click. Oops, sorry, wrong button here. Let me get off this one. Too many button points. Okay, I'm going to do it inside with my mouse works real quick, but you guys can watch it on the screen as I do it here.
Out there in the presentation. Oh, that's cool. Yeah, so it depends on how you want to do it. You can always operate here, so you just click and drag, and then you can use the scroll wheel here.
Okay, guys, I need you to hold it on a scene for me. I'm trying to demo out there.
You good there? Oh, pardon me. So we're locked on, man.
All right, so what it's doing now is we created kind of a minor line here, but using the video, I clicked on the video and it pulls the geodata from exactly where it's looking. Now it's plus or minus a meter or two, but let's be honest, when fire's moving through, a meter or two is probably accurate enough for real-time data. So we click on it, it creates the fire line, it's saving it right now, and then once this gets saved up, we'll be able to refresh our phones and you'll be able to see that on your phone as displayed out. So you can create data straight from the video stream and pull it out live. In addition to that, one of the things that we've got working that hopefully we can demo here in a little bit is real-time predictive modeling. So a lot of the times the flaws with fire prediction modeling is it's based on one set of conditions. It takes 2 to 3 hours to run this high valid model, and then by the time you get the data, it's, I don't want to say useless, but borderline useless because it's really old and the fire's either moved on or you've had real life conditions like tanker drops, dozer lines, etc., that have impacted that model that aren't reflected there. What we can do is we're working with a company called Flame Mapper that can run their models in near real time. And so they can use our video as a truth source to see, okay, that's the ignition point, we drop a point, they run a model, and within a minute or two, they're able to come back and have the predictive model updated and run out on everybody. And then you can adjust that model in real time. So if we witness a tanker drop or a dozer line occurring, you can model that straight from the video and really get that real data in and try to bring that mapping cycle down from once an operational period every 12 hours to try to get down to 12 minutes, right? Or even best case, if we get a really good workflow, you can get real data out in 12 seconds because it's click, click, save, and off you go because all of this is occurring in real time. And what's neat is while we've got this here, streaming here, we've got it out on the web, we can also set it up so that if you've got a GIS analyst that's either back at an incident command post or is forward, sitting at a headquarters element somewhere, we can set it up that they can receive this raw stream direct to their devices so that they can sit there and do all their mapping from the comfort of their office. And the latency on that, when we set up that direct connection, is anywhere from about half a second to 2 seconds. So you're talking very minimal latency to get a live feed out to folks. Jeff, are you getting the comm stuff ready? So what Jeff's going to demonstrate here in a second, hopefully. it working?
It is.
Can you try, Chase?
Radio check 1, 2.
Hold on real quick, guys.
Might have to end that call and try again. Yeti.
Try again.
Radio check 1, 2.
So if you can hear inside here, Jeff is talking through the airplane to the ground control station. So now we've got a VHF repeater on board the aircraft. So you're able to extend communications down the digital link. And what's really neat, here in a second too, if we set up a conference call, I'll be able to talk through my cell phone, and it's going to go through the internet over to this network, up to the airplane, out VHF, and down to a handheld. So now you can extend communications, not just handheld over an incident, but you can really anywhere in the world with minimal latency. And it is bidirectional, so it'll pick up anybody on the ground and share it out over the cell phone. The best part about it is you have the mute capability, so if somebody's got their cell phone at home and don't realize they're on the call, they're not broadcasting out to everybody. You can sit there and mute them out. So you're trying to bring in multiple sets of intelligence. Should be ready. Says ready, Jeff. Well, while that's working out, let me get some in here. No luck.
Oh, that's working for me now.
All right, well, Jeff's working up the call. A couple other the tools we can use. So we realize that ArcGIS isn't the only thing out there. ATAC is coming out quite a bit. And so we fully integrate with ATAC. So actually, Brad inside is taking this video feed in live, and he's putting it out through the Colorado ATAC servers, so that anybody who's ATAC equipped will be ready to go. So ATAC, ArcGIS, I mean, any pretty much situational awareness tool that'll take in video and the metadata, this will stream out to in real time.
So again, when this one's flying on an incident, then they just fall under air attack, right? That's who's controlling, we're talking.
Yep, A-firm. So we've got airband radios in here, ground-bound radios. You're on a hold call there. Airband radios, ground-band radios, and the aircraft's also equipped. So one of the, I know the limiting factors that there's been a lot of feedback on UAVs is that, well, it's cool that the ground station has a system. If the airplane doesn't and you're too far, how are they talking to people on the ground? So that's why we've added these radio systems to it, so that we can maintain communications and fall under air attack. And so it's we fly barometric altitudes, just like anybody else who gets the altimeter code coming into the stack. Same thing here. We plug it in and integrate in with that. So. Comms check 1, 2.
And we can.
How are you doing today?
Well, how about you?
So yeah, that's cell network to here, up to the airplane, down at VHF.
That's just VHF, right?
It's VHF, but we have the option for 4 radio systems we can put on. So we can put VHF, UHF, P25, and airband. So right now, today, we're just flying, it's a P25 enabled VHF. We don't, obviously not doing P25, but we could. And then we've got the airband equipment to add to it, so that you could have multiple freaks. Currently, as configured, when you launch, you're on a set frequency, but we've got some stuff in works that we just weren't ready to demo today, where you could actually change the frequency from the ground. So we'd be able to send the command up and monitor different frequencies.
Okay. You didn't hit mute?
No, I'm on mute. I think it's mic in there.
Okay. Yeah, so we can conference anybody in. We currently hold the keys to who gets on for the call. We'd like to turn that over to you guys. Yeah. But it's very easy to do. Basically, you pick up your cell phone. You could be anywhere in the world. You can talk to the guys on the ground. Right. So you can be sitting at home, sipping margaritas, watching you guys do a backfire mission, tell them they messed up and drag you.
Because of the margaritas, tell them to just
Exactly. And that's where we're open and always looking for feedback, because we've kind of, I don't want to say developed this in a vacuum, but we've developed this and really haven't received a lot of feedback on, is this good, bad, what would you guys like to see as the end operators? So please let us know if there's things that you want to see improved on, or say, hey, that's not realistic, I'd rather have this, because we're always open to those course corrections.
And if we do put 4 radios on there, we can all talk independently, or we're going to have them cross-dock.
So primarily this platform's for communications, or is
Can
it, and also mapping, right?
Mapping, yep. We're trying to go, so we don't have it on this, honestly, because we're trying to move away from it, but you could use this just like a NIROPS asset, where you're going to just go up and mow the lawn and do infrared mapping, right? That's one option for it, and it'll do it. We're trying to say, okay, sure, you could do that, but in reality, we're trying to say, what does real-time video do, and how does that help improve situational awareness? So moving out of the mapping realm into the more real-time situational awareness realm, and then, video is a part of that, but then the next part is voice comms, and how do you get that?
Prediction, like fire growth prediction.
So if you got give me a second here.
I'm old school. I use black tie, white tie.
They're using the same thing. Same anytime that you get a new dozer line or a new airdrop, we'll go in, we'll do the where it was cut, and then now you can go into the model. You can say, okay, now this is here. Rerun the model, and it'll say, okay, there's a good cut here. Now let's attack over here, right?
So whoever's running, they're like running fuel models, wind, they're running all that stuff.
Fuel, wind, terrain,
Topography.
Topography is a big part of it. The relative humidity, temperature, all those variables. So
And
they're
all
running
that's
the full
going in, and that's what they're getting their predictions off of, right?
Yep.
All right.
They run it in a minute or two. So if you see here, so we ran this yesterday off of what we called the meth lab, or the that we're just looking at, right? So we said that's probably a good choice of an ignition source. So there, the guy in California is pulling this video in live. It's about a half a second to 2 seconds late. He can click on it and say, that's where my ignition point is. So we'll simulate that, hey, active fire is there. He can click multiple points and say, there's fire burning on this ridge, and then he can run his model. And then from there, we can see and map a dozer line. Let's say we see a dozer moving along, and we've seen it, and we can say, yep, that's good, right? We can barricade that off. He can rerun his model and say, okay, that flank has been taken care of. How do we now adjust our focus? And so you're getting this real-time feedback, and we're talking in the order of minutes here, between data coming off the UAV to models run to in y'all's hands to make decisions.
So all this would be like going through if on an incident, it'll all be going through your meteorologist and your F-band and everybody else is gonna run these models, right? Or will it always go to California?
No, it can go wherever you guys want. We partner with a company in California as a provider for us. But if you guys have your own models you want to run into, this feed can go anywhere in the world. You just tell me where, and we'll find a way to put it there. And the max latency you're going to deal with VPNs and security and encryption is about 20 seconds at max. Depending on co-located like this, you're talking half a second. And the online feeds we do, or we can put it out over the internet, and it is encrypted full end-to-end. So there's no worry about anybody getting in or the public getting into it. You can have a version that if you want to be released. So for example, we don't have it on this code, but in parallel right now, I'm running a feed that's 5 minutes late. So for whatever reason you wanted to share data, but you wanted to be able to, what I call the Janet Jackson, emergency pull the feed, you've got a 5-minute buffer, we can pull it off before it gets to, God forbid somebody getting hurt or something like that. You see, right?
Real technology's here.
What we're trying to move into next, and really looking for feedback on this, is we've worked with the company to come up with it's essentially about a $500 one-time install beacon on a dozer that goes just off their power supply. And from there, we can pick up every second we get a chirp from the dozer, and then we can take that and map it in UAS map, just imagine that line up every second, dropping a point.
Do you think there's at some point that you'd be able to map not just equipment but people?
So we're looking really hard at that. Cell phone wise, if people have their cell phone on and have a connection, we can do it. We're trying to say, are there ways to do it without, reflections off of people's helmets, things like that. So right now.
So that's what's on that feed. So
but as soon as I dispatch,
no SA along with it, but you can get a real-time feed. This is probably 15-20 seconds latent. The other one doesn't work as well on the phone right now. Once we get that up and running, hopefully in the next couple of weeks. He's our lead coder, so we've been doing a whole bunch of stuff. But once we get that up and running, you'll have all of this directly on your cell phone. So what we're trying to do is, if you don't have ATAC, we can mimic it, right? But we can also make all these layer files and feed that into ATAC as well.
it's what the military's been doing now.
And soon, we're hoping to test it today, ATAC can actually take over the camera. Zoom it, scroll it, whatever, wherever you want to look. So if you've got a group of guys that have an internet connection, and if they don't, we can provide them an internet connection.
But if we're out in an environment, we can track.
They'll be able to take over. So the nice thing about, we use mesh network radios. So if we've got a guy over, let's say he's up on the ridge, he can connect to the aircraft, which connects to the ground, which has an internet connection, which means he has an internet connection. So we give you a Wi-Fi dongle on the radio, and you just tap in and you can do pretty much whatever you need to do. It's not super fast, but it's fast enough.
And all of a sudden he's been gone for 30 seconds.
I mean,
the operator gives the operator. Sorry, I got to do one else.
So the other thing that we can do is that person gets all the live data, but they can also take over the camera without going through stuff.
We've got video evidence of him literally crossing the line and doing fishing activities. We were doing this off of Dana Point, California, reading the registration vehicles off the side of the boats. And one of the California Fish and Wildlife guys was like, I know that boat, and they keep getting away from us. Like, well, it's hard to contest now. And the other thing we do, so live video is great. Sometimes from a GIS analyst point, you want to say, hey, I think that area has been but maybe the line, I want to go back and see it. So what's cool with this video feed is all of this is archived as a storage in 5-minute increments and stored so it's accessible online. It's just a file you download. And so they can pull it in, and there's a search feature where you can say, hey, I want to see, draw a box on the map. I want to see any video in this area that was from 12 in the afternoon to 2 in the afternoon. And it'll search through our entire data set. It'll say, here was yesterday's video, here was today's video. And so you can pull that up, and your GIS analyst then has access to it all. So again, it's real. And then from there, again, they just click on the video and map the line, update the incident map, and out they go.
Ready to check, make sure nobody's messing with your ride. Call an airstrike in on it. I thought you might be down there checking it out.
Yeah, so next steps, what we're going to do, so this will be in the web app. We're going to add all the transmissions coming from you guys is push talks. Now you've got true SA, right? Now we're getting air to ground or each individual unit all the way up and out. So you can be sitting at home, you can be listening, kind of gets into that, do I want to be self-critiquing type of thing, but it's up to you guys. You guys tell us what you want, but we're going to overlay the audio over the video, so now you can look real time. Even if you're coming up to the incident, you don't know what's going on, you can hear all their comms, even if you're out of radio distance.
And really where we want to move to on the web app, and this is, again, we're really looking for input here, is it always comes into a question of who has the responsibility and the authority to task this thing. Who tells us where to look, right? Because we look at it as we'll look wherever you guys need us to look. We're not trying to dictate where it is, but where does that tasking authority lie? And then how do we create a system such that, let's say there's a group on the ground who's looking at, on their phone, they're looking at it, they've got the blue dot where they are, they see the fire moving to them, and they say, shit, I need to see something now, right? How do they submit that request, and can they send that back through and it gets approved for us to move the camera from one spot to the other, right? Who determines what's most important to see on a given incident?
Or you can just text us directly.
Yeah.
So we do have a way that we can put in our web app. You can text directly to the controller.
Well, I think that would be like the hang up, right? I think on an incident, we wouldn't want just everybody texting the operator.
Exactly.
Right?
Yeah.
You for sure didn't have to run through the proper chain
Of command. Yeah. Exactly.
But that's why, because you might think yours is priority, but over there is, and all of a sudden you're pulling that thing off there, and
but then you create a headache for somebody else. Right?
Yeah.
So the whole point of these is to hopefully back down on the ass pain that's involved.
Yeah, right.
For everybody. But if you've got to hire a guy that's going to go through and say, okay, this one's first, this one's second. How long does it look for? All that kind of stuff. Now you've got a new job, and you're adding to people's headaches and that kind of stuff.
Well, there's my camper.
So that's the meth lab that we modeled this on.
Yeah, so you can see this is the theoretical start. So this is taking into account yesterday's winds and how it would model.
You know the trash around there.
In fact, if you want to take this over, I'll get Shay to run put your new one. Which new pocket?
Answer any more questions for you guys?
Yeah, that's legit.
Yeah. So
what
we're hoping soon is we'll also have a LiDAR and a multispectral imager on here as well. So theoretically, we can go and we can get you vegetation, moisture densities, as well as good terrain mapping and all that kind of stuff. But that's kind of what do you want to do type of thing. But there's also when you've got an inversion layer and your smoke is just sitting on top of you, and none of your helicopters and none of your tankers can take off and get low enough.
Yeah.
Just send this up, right? And then we can say, yeah, here it is, here's how it's moving, all that kind of stuff.
Right.
So once the inversion breaks off, now you can go attack it. And then you also have your guys on the ground that have some sort of overwatch to them to make sure that they're safe as well.
Yeah. Because I can't even tell you how many times this year in California where they shut down all your resources, because
Yep.
The smoke inversion was so bad that they didn't fly all day.
Yep. Yeah, and that's where you go to us and you say, hey man, because the UAV doesn't care, right? It's just I'm looking, and the sensor we have looks for heat. So we went with long wave instead of mid wave. Mid wave will get sun glare off of clouds, and then it'll just reflect, and now you think you're looking at fire, but you're looking at the sun reflecting off the clouds. Long wave just looks for heat.
Yeah.
So now we're just looking at heat on the ground. So now we're going, okay, here's where all your heat sources is. Here's your heat intensity. Hopefully soon FLIR will update their cameras, and now we'll get your radiometric data off of the camera as well, straight to your cell phone. So you can say, fire's hot, right? However, if you're looking for hot spots, and they found this on the Scan Eagle like 2-3 years ago, they thought they had a hot spot. So they sent a group of guys out in the middle of nowhere, and then as they're coming up on it, well, it turns out it was just a deer taking a rest. Deer got up and ran off, and they're like, no, they're not a hot spot. So that's what we're looking for. We want to get that radiometric data that says, no, it's not 300 degrees, it's 98 degrees or 100 degrees. Probably not worth sending a group out to go put out.
Yeah.
So.
And then what would the pickup truck cost be, right? That's what's going to be the thing with it.
We are cheaper than a Type 1 helicopter just to show up, for us to fly for 8 hours.
Yeah. So that means that this isn't just a hope.
Yeah.
Because that's what they're going to look at, right? It's like, what's going to cost us more money?
So a Black Hawk, a privately contracted Black Hawk to show up is $28,000 just for a day, just to show up. And then they're like, I don't know how many grand an hour they are to operate. We're half that to operate all day. So
super cool, man.
Thanks. And if you got anything you want to see, so what we've been doing is a lot of what we have here is based off of firefighter input.
Yeah.
If there's something else that you want to see, let us know, because what you want is what we want, right? So
Do you have a superficial or kind of a generic cost or price breakdown without getting into too much granular detail? Just
yeah, I can send that to you.
all right.
That's no
or even
problem.
Just to Stacy.
Yeah, definitely.
Let's see.
Send me an email.
Yep.
Because I gave you guys my
Yes, sir.
thing. Send me an email and we'll send you kind of rough costs of what it
Yep.
takes to operate.
Yep. It'll be from Colorado Mesa University. Yep.
Yeah, definitely.
That'd be awesome. I love the communication piece.
Yeah.
Being able to go from phone to the radio to
Yeah.
to the link to the.
So right now what we have is
You were saying.
yeah. So it runs over LTE, but it has an app. My next hurdle that I'm trying to give is to give the airplane a Google number. So now anybody, theoretically, if you have the number, it'll still go through us, but you can call the airplane via a phone call. Because right now it goes through an app and LTE, but in some places your LTE or your data is not good enough, right? But if I give it a phone number and you've got one bar, you can just make a phone call, and now you're saying, hey, come and find me. I am at this location. I go, yeah, roger that. Here we are.
How do you license your repeater, especially on VHF?
So, so we use an FCC approved. We have. We use the what's their name? Santa Barbara County. All right, the amateur radio clubs, FCC regulated.
They use ham frequencies?
Yeah, it's their FCC approved to use. So they said, and they're actually building us a new antenna. So we've got a little antenna on there right now that is, it works pretty well. It works out like 5-6 miles, right, to receive. To transmit, that thing will transmit, 100 miles at altitude. Well, that's great, but I need to receive, for 20 miles.
The challenge you have, especially when you start doing VHF, is your footprint gets humongous as you go higher.
Yep.
And that's what we always are challenged with licensing our antennas for radio communications.
Yep.
And that's why we had to go away from VHF. Actually, law enforcement public safety had to go away from VHF because the footprint of every single tower was so huge.
Yep.
So they go to 800 megahertz.
So the nice thing about this is the repeater is agnostic. So I take whatever radio. So right now we have a Motorola APX 4000 sitting on there. So VHF only. However, I can take a Motorola APX 4000 that's in the 800 megahertz band, right? Or UHF. Same interface, even if it's encrypted, right? Everything runs encrypted. We take it in. It's all encrypted all the way down, and we retransmit it encrypted. So the encryption stays on the radio. It's not on the box.
I think we just have to remember we can't use our trunk system for that kind of stuff. But we get very dependent on that. We have a statewide trunk system. But we have conventional, national, and statewide 800 megahertz. So what kind of missions have you guys done outside of wildland fire with this?
So we do NOAA illegal fishing operations.
No kidding.
Oh yeah. We're gonna do vineyards. So we're gonna go to Napa, and we're gonna take high-resolution imagery that'll be taken and put into Structure for Motion, and then they'll make a 3D model out of it, and they can see their vineyards. We'll do multispectral vegetation management missions. We have a contract with one of the two large energy providers in California to do public safety power shutoff missions. So what we do is we fly it prior to the wind event, get a baseline, and then go back and fly it after the wind event and say, this is messed up, or this has come off the insulator, we need to fix this, we need to do this. Right now they're using helicopters or just people on dirt bikes, four-wheelers, trucks. Some of these places are just like this, so remote, you can't get into it. What they do is they'll put, instead of us pushing out real-time data, they're not as worried about the real-time data, but what they'll do is they'll hand us a journeyman, a lineman, and say, hey, look at this as we go. If you say it's good, we're going to re-energize. And so we go from circuit to circuit, and they look at the video and they go, good, good, not good, send, and it's all geo-rectified, so they can say, the pole at this geolocation, you need to go fix the insulator. They fix the insulator, turn it back on. So there was, Up in San Francisco Bay Area, they had their power off for 72 plus hours. You know, everybody's food spoiling, everybody's losing money, and the PUC, the California Public Utilities Commission, came in and said, unacceptable. You will turn it back on quicker. So they did was they said, okay, well, you know, we only have so many helicopters. Helicopters are expensive, and all those guys, they have at least one crash a year. I mean, PG&E had one crash last year, killed 4 guys, right? Plus, the thing with the helicopter is California has a lot of airfields. However, depending on what you need, you may not be able to get gas at that airfield. So now you got to go get gas. You get off the helicopter, you're not going to do hot fuel, so you get off, go to the bathroom, get something to eat. Right now you come back, an hour later, you're ready to go, and depending on where you're at, you're an hour out. Right, so now we've lost 2 hours of collect, so because of this, and helicopters only fly for so long.
No request from law enforcement for anything yet?
So we've talked to Santa Barbara County heavily. We are going to do a demo for their SWAT team soon. Our schedule is getting a little booked with this, the vineyards, that kind of stuff. But we're going to, it's one of those things, it's public perception.
Well, it is a little bit. I think we can overcome that. But
yeah.
As I'm sitting here watching you guys, I'm like, a lot of our, with unmanned aircraft in general, is using your imagination.
Oh yeah.
And sometimes it's if you use your imagination, you find out there's a lot more value in it than you realize. My thing is, when I see something like this, I'm like, and if I had one of those up all day long and that car just ran from me, I just lock onto it, follow to its house, and we'll catch the guy. You don't ever have to chase him, you know, or a foot chase, or an overwatch on a tactical operation. And we're just starting to realize that we haven't had a good enough imagination. But even, I don't know if you heard my story about the big mudslide we had. 3 guys got buried in it. And it was one of the biggest in Colorado.
At some point, I could see Overwatch even being, I don't know how much it would take to do a big city, but a smaller geographical populated area, you could even say, well, that crime happened yesterday at 1:32 p.m. at that address. Go back into the data. It's metadata, but now you're targeting a specific time and location.
So the military...
And then say, oh, that was a white Ford Mustang 1985 with license plate blah, 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 and follow it to wherever they went.
Oh, yeah. No, that's surveillance. And that's the part people are scared of, but they shouldn't be, because I can do the same thing with a car. I can do the same thing with cameras at a station. You know, it's just getting them to break that paradigm. But the surveillance component is trying to surveil a car, believe it or not, through a city.
It's hard.
It's dangerous too. You got to drive like an idiot to keep surveillance up on it. And usually you're shadowing with marked units. They have to drive like idiots, and so surveillance. But Overwatch is more, you've got a stagnant operation, and you don't, you know, you want to avoid like a we call blue on blue shooting. You know, so you want to know where everybody's at and have a common operating picture. And that's the Overwatch. And for me, the guy sitting blocks away trying to run it, having that would be huge.
So we come from that world where we sit and look for days, hours, months, whatever, right? At this point, Jason's not going to advance on a compound unless they've sat there for 3 days, 3 preds over it, have seen every door in and out, know who's in there, who's coming out, what their daily, you know, at this time he goes to the bathroom, at this time he takes his kids to school. This is probably the best time to do it.
So what got me going on ATAC and drones is I found this retired Delta Force operator that moved into our community, and first thing he says is, are you guys using ATAC? And then thinking about drone and Overwatch, because so much of what we do, and he even says that, our SWAT operations are just like what he did in Iraq. He said, big difference is I could never use tear gas. We use the hell out of it.
Yeah.
He couldn't. So,
Oh, you just use something a little more lethal.
Well, but he said that their last few years there, he said they were having to go get search warrants. And I'm like, well, okay, you are much like us, but more resources.
Yeah, one of the kind of bad things right now is they're making them wear helmet cams and that kind of stuff, and then they're sharpshooting them on the backside, and it's like, man, can't send guys into an extremely dangerous situation.
Well, that's the world we live in. Our level of force has to be a little more measured. We just shot a guy last week, but it wasn't SWAT, but it was a rescue operation. And of course, we just had a cop killed yesterday. They were using drones on that event, but
Yeah,
small ones.
I was following that. It's like, man,
I don't know what it is about Colorado. Why we keep getting them.
California. I mean, it's crazy people everywhere, man.
Yeah, there's. See the elk over there? You get the big
We've had to do a lot of work with Esri to get it to this point.
Yeah.
They're when we first started using it, it was really choppy, and what we found is we were pushing. I don't want to give out too much data to the people that are listening, but we were pushing too much data, so we had to back off a little bit.
And I think that's the problem. My GIS guy, that's the thing I got to do is going back sometimes because he wants to throw everything that it can at him. Like, no,
Yeah.
you know, we don't need all that. But
Yeah, and Esri is extremely powerful, but you can overwhelm it if you don't have a big enough computer or GPU. So. Yep.
What was it you asked me to pay for GIS and going to? Oh, so what are you guys going through and getting any type of fire qualifications for your operators at all?
Yeah, we're all S190, S130. We did all that stuff last year.
So what about like the GIS or the infrared?
So we're not sure if they'll give it to us. A lot of that is somebody else's job.
So you're just delivering a product then?
Yeah, well, I say that we can do it.
these for the taking?
Yeah.
Oh, good.
I say that is we can do it, but there's always like a little bit of pushback from So there's a Overwatch Imaging has a really nice camera that NIROPS is using, TK9, right?
That's why I was asking, because I've been with NIROPS since 2000.
So we could put a TK7 on here. Get the exact same thing as a TK9, but whenever you need it, right? It's not going to go to the next incident because we can't go to the next incident, right? But the nice thing about that is that it does the work for you. We've been in talks with them for the last year or so about integrating. They have the files to do it, but right now for us, this is all self-funded. So it's basically friends and family that have funded lots and lots of money into us. So what we're doing is from the FAA standpoint it's easier to do this type of work than some of the other work, right? But you get everybody used to it, and then you can go into the other work. So, making sure that people are safe, people can get behind that, right? Now, looking at pipelines and that kind of stuff, people should get behind that because that's also a safety thing. But that's coming, and the nice thing about working with some of our electric providers is they can set up their own TFRs.
Sure.
So for us, we have a BV loss waiver that says any TFR you can fly in, SOSC doesn't want to talk to you. So we have carte blanche as long as it's a TFR, we can fly beyond visual line of sight.
So under the Department of Interior, working with Matt's group, Precision, are you guys only allowed to operate under a TFR under that contract? Or will you?
So that's Overwatch's 44807 BV loss waiver. We haven't looked into. We have their info, but most of their stuff is done through DOI's approvals. But we have 400-foot waiver. We have
really what I'm keying on here is that I've been talking to Brad Kecker, it's the Office of Aviation Services, about. So we have the fire contracts, but migrating out of just fire contracts into non-fire applications, which we're more interested in at the USGS. And that's why I'm kind of interested in, if you guys have a LiDAR capability in the future, seeing if we can put it under the umbrella of the fire contract. I don't know how it was written.
I can point you to that data.
I actually have a copy of the contract because I was working with the Office of Aviation Services was, hey, can I look at developing our own contract for non-fire based on what fire contract says? It'd be interesting
we can just work under the existing contract that's already in place to do the non-fire.
So another option for you is we have the ability to make our own airspace. So not beyond visual line of sight, but we're allowed to daisy chain observers.
Yeah, that's kind of how we do it.
So like for this airspace, we have pretty much all the way over to those mountains, all the way over here. We asked basically the moon, and FAA, so unlike the drone zone, we can have actual conversations with Western Sector and say, hey, this is what I want to do. This is how I need to do it. Can I do this? And they'll come back and they'll say, yes, no, you can do this, but you can't do that.
Is this the aircraft that's being carted by the Department of Interior?
Yeah, this one and the other one over here.
That is the big sticking point, is trying to get carted aircraft.
Yep.
The Office of Aviation Services blesses.
So we tried to do it last year, and if you're not in by the end of February to add tails, you're done for the year. So we added our tails this year, end of February, so make sure we got them in.
What are you looking at for the LiDAR? I forgot I was telling her.
So there's a couple missions. So vineyards are looking for it, but the power companies are also looking for it. They want to see, it's mainly for vegetation management, encroachment, that kind of stuff. But when you add in multispectral and you can see vegetation health, now you've got how close is it?
And that's before you guys took off. That's what I was telling you. So what we're doing with the LiDAR, we thought we could run just LiDAR, but due to being able to do some QA/QC on the data, we're actually flying LiDAR. Then we're overflying with a photogrammetric payload, so we can assign that RGB value to the LiDAR point cloud. But we're also using the photogrammetry derived point cloud for basically QA/QC of the LiDAR data.
Yep.
It sounds a little backwards, but we found that you have issues like beam divergence and things like that with the LiDAR that starts creeping up.
Yep.
So that's kind of how we're operating right now with our LiDAR unit.
Okay.
So we're doing photogrammetric collect, with an RGB camera, and then with the LiDAR.
Gotcha. Yeah, so what we're trying to do is we're trying to do it all at the same time.
That makes sense. If you got the payload to do it.
Yeah. So
actually, with our the Velodyne Puck LiDAR unit that we have, it's not as accurate.
Mm-hmm.
We do have a dual mount for it, so we do have an RGB camera that we can mount underneath the LiDAR unit and do a dual collect.
Nice.
We don't really typically fly it that way because it reduces our payload and our flight duration.
Yep. And that's always. You want this?
Yeah, I'm going to do the recovery brief here. Okay.
Yeah, that's always.
All right, real quick to kick off the recovery brief. So we're established in an orbit up here. What you're going to see is we're going to bring it down over this way, lower it down a bit, lose some altitude, and then from there it's going to come right in along this ridge line here. It's going to enter what we call left traffic coming in. We'll turn left base to final, and then final approach. You'll see it slow down and transitions from the airplane to helicopter mode. You're going to see a lot of what we call the wobble. So don't be surprised if she's doing this kind of coming in, and so that transitions, especially at this higher altitude. She'll fly over the top here and then come down just like she launched, but in the opposite as a helicopter coming down. Same thing as last time. We ask that keep at least this clear so that as pilot and communicators we can get good calls. Maintain minimal communication, treat it as a sterile cockpit type of environment until you hear basically the engine die, and then we're back to normal. In the middle, these guys will be calling out altitudes to me as she comes down to land. They'll call safe on deck, and then we'll get her shut down and put away for this demo. Any questions? Okay, same time, or one last thing, just same thing as last time, try to get everybody behind this fence line for recovery just for safety's sake, and we'll bring her in here shortly. Thanks.
Okay. Hope everybody's having a good day today. We will be bringing the aircraft in shortly. It'll fly on a downwind, kind of where I've got the camera pointed now, out in this area, and then it'll go base and come pretty much right over me. And at that point, I will try to swing around and capture it landing. One note is that when the aircraft is in its transitioning to its VTOL mode, it does get a little wobbly, so it looks like it's wobbling around. That's normal, so don't be surprised when you see that. Okay, the aircraft is coming in on its downwind now. I'll try to pick up on the screen here in a minute. It's not quite in your view yet. There, I think the camera's having a hard time focusing on it. Turning base now and coming around. If you can't see it on the screen, it's right above those trucks, swinging around in a circle. Coming in on final now, it's headed towards us. Aircraft is in VTOL mode now. You can see it wobbling around. You can probably hear those props. It's going pretty much right over the top of me. There it is. And on the ground. And there's the motor shut off.
Like she learned from yesterday.
Yeah.
Yesterday she came down pretty quick.
A little slower today. weigh the aircraft. That's how they tell how much fuel it used. Okay, we're getting ready for the next aircraft. In this case, they're going to launch two different aircraft. The first one is going to be a VTOL, a small VTOL, much smaller than the one we just saw. It'll take off vertically and then transition to horizontal flight. And then the second aircraft will be the Puma E, and it is a hand-launched fixed-wing aircraft. Probably about 20 minutes away from that transition, so we'll try to keep you updated. So in this evolution, we'll actually have a video feed, which is the drone system. I0 will use radar to track the drones, and we'll have a camera that zooms in on tracks them, and I'll try to share the desktop of what you can see on the I0. Here in a moment, I'll switch over and show you what that looks like. Okay, what I'm is the I0 system. A radar radar system. Radio camera. The way this works, it actually uses the radar to detect the drone. So launch or will shot view as well. Testing 3. Testing 1, 2, 3. Some issues with Testing. Testing. 1, 2. Yeah. Three. One, two. Okay. Well, I'm getting. Everybody in YouTube land is listening to me talk about my microphone.
So shortly turning All right. Testing 1 2 3. Testing 3.
That's kind of quiet. Go ahead again.
Testing 1 2 3. Getting ready to test our environment Quantix and Puma LE. Broke.
I don't know. It's just this crappy audio.
If we have like hardly any viewers, we can set up a thing since we're working on audio.
This microphone I can pick up, but I don't know if it's
some information about what we're going to do here with the flights.
Thank you, John. My name is Robert Boyer. I've been with AV going on over 10 years now. One of the senior test pilots with our R&D side of the house. So like John said today, we're going to demo two different platforms for you guys today. We're going to do our Quantum Mapper. It's a VTOL, so a forward transition flight. Very simple. It's run off of a tablet. Any user can use it. If anybody wants to step up to the plate, you guys can launch it today for us. For that platform, there is no loss of link. I can shut down that tablet as soon as I launch that aircraft. It's going to continue to do its mission. It's going to come back in forward transition. It's going to go to its VTOL state, and it's going to land right where I launched it from. All hands off, nothing to do. If the aircraft does get squirrely, I'll have the E-stop, emergency stop, stops all props. It's just going to fall out of the sky. Hopefully, nothing will happen, but if it does, I'll put it up in the hills for you guys today. Our second platform is going to be all environment. It's our fixed wing platform. Currently, last I heard, there's well over 10,000 of these things out in the world right now being utilized. It's an ISR platform, so intelligence, surveillance, and recon. Hunter actually just got out of the Marine Corps, used it downrange himself. Puma can be splashed down in just about anything. Water, mud, sand, whatever. It can be flown in all types of environments. It's robust. It's our landing style is what's called a deep stall landing. So this thing will come in a forward transition flight. It will flare up and then it'll fly gently down to the ground. It hits the ground at 60 Gs. The wings pop off, the simulator pops off, all meant to pop off. Usually everybody, when they see that the first time, they panic, they say, we broke our airplane, we really did. There's a lot of breaking points on that aircraft called our snap screws and our snap clips. Those are meant to break. It helps to reduce the damage to the airframe itself and to the wings, the surfaces. We'll demonstrate all that. We'll show everybody today on that. Once we do get the Puma up in the air, I invite everybody to come on over to our station and play with the camera. As soon as we get into our autonomous flight mode or navigation mode, you now operate and low light. I've talked to some of the fire personnel here today. So we have 3 different sensors on our payload. Our payload is the Manus I-45. So we've got 2 optical EO cameras. We've got a wide sensor and a narrow sensor. Each one of those sensors has a 3-time digital zoom. We have a near infrared sensor, which is a 3-time digital zoom, and then we have our low light, which about a year ago we put a greenish tint over. We don't want anybody to get MBGs, it's really not. But that also has a 3-time digital zoom as well, and we also have an illuminator on that. Now it is just an illuminator, it is not a laser designator. Illuminator helps the warfighter downrange. Say Hunter would be flying this downrange. I'm going to show you guys what the end stitching all the mapping that we're doing today with our quantums. We're going to do a little 12-acre mission. Should take probably about 20 minutes, 25 minutes of open. But we'll show you the end use of that as well while you guys are playing with the Puma. All right, everybody got any questions? You guys, unlike the other 2 platforms we saw today, safety standoff, really for phonics, 10 feet. Okay? If that thing gets squirrely, then, run. Right? It's not going to get squirrely. Puma, same thing. As soon as we launch, you guys, anywhere behind the launcher, you guys are safe. When we come into land, I would ask that we do keep the path clear. So we can land in a safe manner. Then you guys roll up, flip over, play with it, pick it up, get all along over again. You guys are definitely here from flight. Quiet. Max throttle. It's called our launch assist, and it's just to help the operator hand launch this thing. So we've got some. Whatever.
There we go.
Can you go?
What do you need me to do?
It's
Whatever you were doing?
Yeah.
Just
a minute ago.
1 minute ago. Okay.
I think we're there. Go listen to it now.
All right, what do you need me to do?
Nothing. I don't think. I needed somebody to go check.
All right.
So I think hopefully we have audio working now. And so
That's the latency.
yeah.
So it's working. Just big latency. Okay.
I think so. So like I said, I think we have the audio working, so we're getting ready to watch the launch of this aircraft. This is a VTOL. It goes up vertically and then tips over and flies. And hopefully you can hear what I'm saying. Spectator through the launch, so I think he's showing them how to do that. We've had 3 very different aircraft here today, and we'll have a 4th one yet. There we go. We have the props spinning now. Oh, they've stopped. Now they're spinning. Yep. Try to get ready to follow this with the camera as they launch. A little tricky. A lot of things in my hands right now. This is the joy of YouTube Live. So hopefully you saw that. The thing is so quiet that I didn't really hear it taking off. I panned up as long as I could. We'll probably switch over here in a minute to a feed from I0 counter drone, which will show us the drone being tracked by that system. So the aircraft is up in the air now, and I've lost audio. Are you guys tracking it yet?
Oh yeah, when it's out front, yeah.
So I transitioned over to the drone tracking, but now the drone has flown behind us, where we've got it set up to only look one direction. So I'm going to go back to video. Here is the aircraft coming into land. Okay, and it's landed.
a lot of fence versus all this logistics stuff.
So they can hear him
Yeah,
instead
that's
of
fine.
us.
It's live.
Those are all watertight. Fuselage, it's a foam core with 3-ply Kevlar over it. So obviously there will be water that does get through Kevlar, because what's Kevlar? It's just tightly weaved, fabric, right? So water does get in it, but you dry it out, pour it out, let it hang dry overnight or sit dry overnight. You're good, and it really doesn't add that much more weight to it. I think the most was just under a pound.
Wow. And this can be hand launched?
This is hand launchable, yeah.
I'll hand launch it today. There's also the bungee launcher, which is right here. And basically just 3 stakes in ground, you pull it all the way back and let it go. Or you can throw it out of the back of a truck or whatever ATV, whatever you need.
Off the back of a ship?
Yeah, back of a ship, a boat. We've done all that stuff. And yeah, you basically just stretch this all the way out. And you hook it up and you just let go.
So
is that like in multiple pieces, or is this one launcher here?
That's one launcher. I have a second bungee cord that's in there, just because it's our asset. We usually have more than one. One makes none, 2 makes one. So that's our philosophy or motto. So the bungee launcher was actually developed for the bigger sister to our Puma AE. It's called the Puma Long Endurance. Fuselage is 6 feet long, wingspan of 15 feet. Comes in weighing close, just basic, we call it slick Puma. Comes in at weighing at 23 pounds, where this right now is at 14.5 pounds. You can obviously add more electronics, more gear to it. It's going to weigh it down. It's going to kill your endurance. It's going to potentially damage the fuselage and or your extra assets that are on board. Where Puma LE, we have it separate, its own cargo bay with its own power supply, its own data supply. And that one actually doesn't deep stall. That one will come in just like a manned aircraft. It'll come in, it'll skid land. It's got reverse thrust capabilities with a LiDAR on the bottom to read the ground. So
what's the payload bay look like on this thing?
So this is the payload bay. That's the ISR payload. Yeah. So that's the Manus I-45, which I talked about before we launched. It's real basic, real easy. Everything's meant to be removed out of here. So it's as simple as that.
What is that? Oh.
So this will, once we're airborne, this gimbal will deploy out, and it's a complete 360 infinite spin. So you can look anywhere you want. Obviously you can't look up, because then you're going to start looking into your wingtips, your fuselage, and then you can't look directly down on yourself. We call that a nadir. It'll nadir itself. We do have a command that you can send to it to command it to lock straight down, and it will turn sideways, so it'll compensate for a roll in the aircraft, and that's how the Puma AE is used for mapping. So it'll lock straight down with roll capabilities, and you just go in a straight line and just map out your area.
Cool. Can you hold that up there for just 1 second?
Or are we allowed to take pictures of it?
Oh yeah.
Yeah.
Yeah. Okay. Good question.
This is the older. This is an I-25, and as EO, IR, same thing. It's just an older. Basically, that's the upgrade. But you can use either one in the plane.
Plug and play.
Yeah.
Yep.
Plug and play. Yeah.
Plug and play.
Oh no, my camera's on. Go ahead. I'm sorry. I don't know what I'm doing.
We'll have plenty of time after. So in here lives the avionics, autopilot, all the wonderful stuff. We have external GPS along with our INS. We got our servo strobe. So those are our navigation strobes. They're not classified as the 3 nautical mile strobe under Part 107 or under NOS. For that capability, we have to strap an external strobe to the top of the center wing when we're doing night ops or anything like that. That would require a 3 nautical mile strobe.
INS, inertial navigation?
Yep. Then we got our battery, our lithium ion battery,
and then our PDU, which is our propulsion drive unit. It's all sealed and everything. Battery has a self-sealing seal on the bottom of it, so it'll plug into, it'll sit on top of the battery prongs there, and it'll seal around that, so you don't have to worry about water intrusion if you splash it down in water, a lake, or whatever. And like I said, everything's meant to come off. I had talked briefly about these. So these are called our snap screws, and they're just nylon injected, pieces. Down the core of the thread, it's hollowed out to a hex head, so it actually shears the top of the head off and leaves the nylon down there. And you just get, these actually come with a little Allen wrench. You stick it down there, twist it out, pull it out, put another one in. Yep.
Once it's broke off?
Yep.
It's all user friendly. Very easy to take everything out, put it back in.
Now, are they breaking every landing?
Nope.
No.
Just the hard ones. So every landing when you fly?
Every landing when I fly. I mean, it might be because, I hit trees or something, but, it's okay.
Right.
Wings come in 3 pieces, so you've got the center wing, and then you have your left and right that get strapped onto it. So there's a guide pin, and then there's the spar joiner. So the spar literally goes from wingtip all the way through to the other wingtip, through the joiner. And the wingtips actually, without that plastic strap on the back, these wingtips will actually lock into place once they're under load.
So no control surfaces on the wings at all. Everything is
Rudder and stab.
Okay.
Our wing tips are up to help with control, since there's no controlling surfaces on the actual wing itself. Yeah. It's extremely, user friendly. It's easily deployable. Once you get proficient with it and through your pre-flight, you understand you can be from out of the box up in the air in 10 minutes. It's really good, for law enforcement, really good for fire, military.
Without the payload, how much is the airframe?
With airframe just totally gutted?
No, just the airframe without the payload there.
You talk about price or weight?
Price.
That I don't know. You got to talk to John Barry about that one. They don't pay me enough to ask those questions. I'm a meat puppet. Plug me in, tell me where to go.
Sweet. Yeah, so this is inside the avionics. Essentially just plug all this in. You let one of us throw it too? It's very user friendly. It's very easy.
If you guys want to.
No, I'm good.
It'll be interesting.
I'll do anything once.
Yeah, that's right. But you're a little taller, so you throw it more.
I know, yeah. I'm out already.
Keep lifting, Dave. Nice.
Definitely rugged. Yeah, it's incredible.
See her fly.
All right, let's go.
Take a beating.
Yeah, they really can.
Keep on ticking.
Yeah. Put that on.
Ready to go?
It's about as simply put together as you can make a thing like this.
You guys use duct tape or some military grade tape? You can use either.
I use gaff tape a lot.
Some military stuff.
You just make sure that they're on tight. The actual aviation part of this is simple.
Hey, do you want to go pull the mission down on that real quick?
Yeah.
What's your minus?
20 kilometers. Yep. 20 kilometers and an altitude of 10,500 MSL.
Way more than anything the FAA is comfortable with.
Oh yeah. Half of the time they're not even comfortable with 100 feet.
No.
And
we go to the military first.
Exactly. Endurance on this is 2.5 to 3 hours, depending on the environment that you're flying in. Obviously, if you've got heavy winds, strong winds, it's going to cut down on your endurance a little bit. If you've got no winds or you're catching thermal, so it's bleeding up a lot, it's using less throttle, you're going to extend out your endurance on that as well. The bigger sister to this, the Puma LE, which I spoke about, endurance on that is anywhere from 5.5 to 6.5 hours. And that is also hand launchable at lighter configurations, bungee launch, or vehicle launchable. Lithium ion.
Like the 2590s or smaller?
18650s. So I don't think the 2590s have the 18650s. Yeah, I don't think those. Those are the same ones as the Javelin ones. There's in that battery pack there is 38 cells in there. I should know that number. I've had to go around counting them before.
What was the flight time again?
Anywhere from 2.5 to 3.
Okay.
Yeah, depending on your environment that you're in.
Yep.
If you guys are ready, we'll get going.
Yeah.
Okay. We'll run through a quick pre-flight. Hunter will launch it out that way. You guys are more welcome to stay right here. Doesn't matter to me.
Okay. Cool.
Okay, recorder starting, set GCS battery warning level check. Same channel, transmitter's on, GPS 4+, good luck. Give me compass, please. Good. Good. All right. Check my mission. Mission is good. Okay. Clear prop. Running up, battery at 24.1. Okay. Clear done stow. Stowing it. Azimuth elevation good. Checking zooms. Good bit pass. Okay, zooms are good. Clear to stuff. Stowing it. Gyros. Good. Okay, left, right, back, forward. Good. Pitot, sir. Good hold. Good relays. Okay, red and green's coming on. All right, ready to go. Where did our wind go?
Just when you needed it. Saw you coming.
Yeah. That's what I'm feeling, yeah.
Go hard. Good.
Yeah, clear?
Clear.
Launching. Yeah. Yeah, it's super quiet. Like I said, the only time you're really going to hear it is during the launch, and that's because you're down here. We've done acoustic testing with this. You can get it down to 100 feet directly overhead before you really start to hear stuff.
Practical range is you see it before you hear it.
Exactly, yeah.
Especially if that guy's standing next to a generator.
That kind of helps just a little bit, doesn't it?
So on pre-program what you want to fly.
Yeah.
Like map if you want to do something.
What's that?
Yeah, you can watch it.
Pre-program a map on this too that you
So
want to buy?
yeah, so on this, so this is called our Mission Tough Book. Let me get it in orbit real quick, and then I can talk to you. All right, orbit 3.
So the little yellow triangle, that's the plane. And then all these waypoints are basically the flight plan.
Oh, okay.
So yeah, so this is this Mission Tough Book. So the mission operator, which Hunter is, so we use what's called Falcon View. And Falcon View is just basically a mapping tool, or a tool that has maps on it, and then we put our overlays on it, our SUAS toolbar, and that allows us to change our waypoints, do whatever we want, select where to go. He can send me anywhere that he wants, and I can go anywhere I want as well. And then we also have real-time video coming down. The avionics that we have on board is our 2.4 stuff, and it's not real spectacular because the Puma wasn't built for this. It was built for 5 megahertz, 10 megahertz channels, where we're on 2.4 megahertz channel right now. So it's kind of killing our capabilities of our payload, and not able to showcase the full capabilities of this thing. You see it really choppy. Yeah, you guys are more than welcome to hold that. Check it out.
Yeah, bislocal. I like that.
Oh, yeah. So it's got all pertinent, flight data, and I'm in navigation mode right now, so it's autonomous flight mode, and it's all I'm doing is just controlling the payload now. I'm looking where I want, what zoom.
Or you say 3 times zoom?
3 times digital zoom. Yeah. So we got 4 sensors on board. We have 2 EO sensors. We've got a wide EO sensor, a narrow EO sensor, and then we have our IR, our near infrared, which is a 3 times zoom, and then we have our low light. Actually, just looked up at my fuselage. Look back.
Yeah, all these cases, you don't need any of these. You essentially just need that one tank case that can hold the Puma, all the wings, and the laptop and everything you need. Battery is this size? Yes.
So right now we're 700, 800 meters out. As soon as I get video again, it's killing me.
We have attachments to basically put that on the outside.
Some big flakes. Do what? Big flakes.
No, I actually just drove out here.
Yeah, so it's looking, at us.
Is this a bungee? And what we're seeing there is the one on the left,
Yep.
right?
Yep. So there's our mission, right? And I can send it through, so we have an A, B, C, D, and they're all connected to each other. You can make them in any pattern you want, but they have to stay connected to each other. And we got 3 orbit points. You can send those wherever the heck you want, left or right hand turn orbits. They're just a basic orbit, not a big deal. And then we have our E to L. So our E echo waypoint is our pre-staging landing waypoint. It'll go out to E, it'll circle down to its altitude or circle up to its altitude, and then it'll drive into the Lima waypoint, which is right here. It'll come in, pop an auto land, come down and land.
Yeah.
You son of a bitch, don't ever stutter.
He was always like, do the stutter thing. I was like, why? I'm just going to throw it. Like,
Hey, let's get that Quanix out of here, dude. Or in the case, at least.
But yeah, I was always like,
yeah, you just put that in the back of my truck over here.
Yeah, let me go crash it first.
Yeah,
then you can then I can write it off.
There you go.
Just a throw. Yeah. He's probably better off running it.
Here, you want this, Hunter, and I'm gonna go do that card.
I don't think he wanted to do that.
So what are you seeing in there?
First off, payload, right now, we don't have
What do they call the 45?
And that is a normal landing for this aircraft. We're going to shut down YouTube. Thanks so much for coming and joining us today.